Hello and welcome to the fifth lesson here in Spiral 5. So today we're looking at two linear relations. So what happens if you graph two lines on the same graph and talk about what they actually mean or represent. So example 1, data about the total monthly cost to rent video games. So way back in the day, in the dinosaurs, when I was younger, you could actually go to the video store, which again doesn't exist, but you could rent video games for short periods of time. So taking you back and walk down memory lane here. So you can go to the video game store and we have two different possibilities, two sites. So down here you can see in the graph, we have one site, Mighty Gamers, and the other one is Sir Game a Lot. So we want to use these graphs, or this graph, to answer the provided or given questions. So, which of the following statements is true? So this is a multiple choice question, something that you would see on EQAO. So I'm going to take a little bit more time with it. Which of the following statement is true? It costs more to rent from Sir Game a Lot after 6 games. So first of all, let's just talk about the graphs themselves. All right, so I'm going to do a bit of extra running around here. We have two linear relations. So what are the things we know about linear relations? We know we can find an initial value. So Mighty Gamers, there's the initial value, all right, of $15. Okay, so that is your initial value. So initial value equals 15. So what does that mean? For Mighty Gamers, if I want to rent the game on 0 days, so it's like a down payment, I have to give them $15. And then there's a unit rate. I'm going to pay so much per day. All right. Now, the other graph, if we look at Sir Game a Lot, sorry, that was Mighty Games, Sir Games a Lot, here's their initial value. And their initial value is $30. So it's more expensive to go to Sir Games a Lot to start because their games, they charge $30 to get, before you even get to play it. Okay? Now we're looking at numbers of games rented. So Sir Games a Lot, all right, if you look at the horizontal line, there's no change, okay? So that means if I rent 2 games, 4, 6, 8, 10, and so on, it costs $30. So they have a flat rate for their rental program. So it doesn't matter whether you rent 3 games, 5 games, 10 games, you're paying $30 no matter what. Now Mighty Games, or Mighty Gamers, you're going to pay so much per game rented, but you're going to come to a point where these two lines intersect. Change colors. All right. So when these two lines cross, that means you have found where they cost the same. That's what that means. All right. So over to the side here, therefore, Mighty Gamers is cheaper at the start. So in brackets, $15 versus $30. All right. But when you rent, so if I go back to my graph here and I pick red, when you rent 6 games, they cost the same. So when you rent 6 games, it will cost the same. Now what happens afterwards? If you look before, I'm kind of running out of color here, before the blue line was below. So all this time, Mighty Gamers was cheaper. At 6 games, it costs the same. But what happens after? The blue line goes above, so now it's more expensive to rent from Mighty Gamers. So after 6 games, Sir Game a Lot is cheaper. All right. Now, this is what you're going to be doing in your head when you look at this. So the first thing you do when you see this graph, you're going to say, hey, Mighty Games is cheaper to start with, but when I get to 6 games, it costs the same. And then after 6 games, it switches. So now Sir Game-A-Lot is cheaper. So now I'm looking at the multiple choice. So this is all, you're thinking. All right. So are you going to write this out on a test? No, this is multiple choice, but this is what you're thinking. So which statement's true? The first one, it costs more to rent from Sir Game-A-Lot after 6 games. So after 6 games, we know that's not true because in the purple here, we just said it's cheaper. So it can't be that one. Process of elimination, that's gone. It costs less to rent from Mighty Gamers after 30 games. Well, we just said that Sir Game-A-Lot is cheaper after 6. So there's no way Mighty Gamers can be cheaper after 6. It costs the same amount to rent 6 games from the 2 sites. That's what we've concluded already right here. So this is actually going to be our answer. Let's take a look at the next one just to be sure. It costs the same amount to rent 30 games from the 2 sites. They're trying to trick you because they're trying to say, oh, this is the number of games, but you guys are smarter than that. You can read the y-axis. So that one's definitely out. All right, so there's the thought process. There's what I'm thinking when I see a graph like that when you're working through. Okay? Next. Kira and Zachary are junior speed skaters. Kira skates at an average of 10 meters per second. Zachary skates at an average of 9 meters per second. So those are rates of change. So rate of change or unit rate, and I'll put K for Kira, is 10 meters a second. Rate of change, Zachary is 9 meters per second. 1,500 meter race. So Kira and Zachary have a 1,500 meter race where Zachary gets a head start. So probably, you have 2 skaters. One's younger, so you're handicapping them a little bit, so it's an even race. So let's figure out what our growth pattern is. So we know that when 50 seconds pass, Kira is going at 10 meters for every second. So 50 seconds, she has gone 500 meters. So that means every 50 seconds, she's going to go 500 meters. So we know the growth pattern here is just 500. So we see that we definitely didn't have to go up to 300 seconds. The race is going to be over before we get there. Now Zachary, he does 9 meters per second. So 9 meters, so that means 9 meters per second, or in 50 seconds, he's going to do 9 times 50, 450. Whoops, now I've got to be careful here. So we are going up by 450, so that's 550, and then we add 450 every time. So 1,000, 1,450. What do we got next? 1,900. Won't be 14, it'll be 1,350, and then 1,800. All right, so assuming I did the other side properly, and I don't see an error, so let's assume I didn't make one. Okay, so let's answer the questions here. How far does Kira go in 50 seconds? So we've already kind of answered that with the table of values. I'm not going to bother graphing it at this point. We've got it right here in the graph. So 50 seconds, so that's 500 meters. And Zachary has gone 550 meters. All right, so we've answered that question. Let's jump down here. What if the race was only 5 meters long? Who would have won? Well, if it was 500 meters long, so from the table of values, here's 500 meters, here's 500 meters, 550 actually. So who got there first? All right, who reached 500 first? So hopefully you're thinking, Zachary, because he's at 550 already. It took Kira 50 seconds to get there. Zachary's still ahead. So in this case, Zachary, because after 50 seconds, he is way ahead. I should say 50 meters ahead. So he's already past the 500 meter mark. All right. What if the race was 1,000 meters long? Who would have won? So again, we've got the table of values. They might give it to you as a graph, all right? But we've got the table of values. So at 1,000 meters, we can conclude it would be a tie. Okay, they reached 1,000 meters at the exact same time. Now, if we were to graph this, what would have happened? So Kira started at 0, 0, so she's a direct variation. Okay. Zachary, he started at a 0, 100, so he had a starting point, but he was going slower. So if they were going the same speed, the lines would be parallel. If he was faster, it'd be steeper, but he's going slower. All right. So if you were looking at the graph to answer this question, at 500 meters, you would have went up. Okay, and oops, that would be incorrect because time is on that axis. Sorry, 500, boom, boom, boom. So you can see that Kira isn't at the 500 meter mark, oops, at that time. She's down here yet, so she hasn't got that far. At 1,000 meters, you can see that they've gone the same distance, and that's why it's a tie. So you can see that from the T-chart, you can see that information, and from the given graph, you can also see that as well. The last graph here, I'm going to, what am I going to do here? I'm going to take this up in the second part video, so I'm not rushed.